When dealing with functions of a real variable, a critical point is a point in the domain of the function where the function is either not differentiable or the derivative is equal to zero. That's the definition given to us by Wikipedia. So let's find the critical point for this function f of x equals negative 8x to the third plus 123x squared minus 270x minus 7. Alright, well, in order to take this derivative, we're going to have to use the power rule for power functions. And to find f prime in this case, I notice that I have 4 terms, and I can take the derivative of each of the 4 terms separately. So the first term, the negative 8, I can treat as a constant and just take the derivative of the power function x to the third. And then the 123, once again, that's just a constant, and I can just do the derivative of the power function x squared. And then the minus 270 I can treat as a constant and do the derivative of the power function, which would be just x to the first. And then the minus 7 also just a constant, and I'm taking the derivative of x to the 0, which is of course 1. So I'm taking the derivative of all those power functions separately. And in the first case, it's going to give me negative 8 times 3x squared, because the rule says if n is 3, like in this case, then the derivative is going to be n times x to the n minus 1 power. Same thing here is going to be 123 times 2x. And then over here is going to be minus 270. And then the negative 7 is going to be multiplied by the 0 from the x to the 0. So the derivative of that constant is just 0. So f prime of x then, the derivative that I'm looking for is going to be negative 24x squared plus 246x minus 270. And what we need is we need to know to find a critical point where this either doesn't exist, but it's a polynomial, so the domain is all real numbers. So the derivative exists everywhere. So then the only other place I could have a critical point is where the derivative is equal to 0. So I just need to know where this derivative is equal to 0. And I need to solve this quadratic equation. The quadratic equation is already written in standard form of a quadratic equation. So I can solve it by factoring, but I'm just going to go for my old pal there in blue, the quadratic formula. I'm just going to plug in a is negative 24, b is 246, and c is negative 270, because I don't want to mess around and try to factor this. So I'll just go through here and let me see. So the x values that I'm looking for critical points then are going to be negative 246, which is b, negative b, plus or minus the square root of b squared, which is 246 squared, minus 4 times a, which is negative 24, times c, which is negative 270, and that's all divided by 2 times negative 24. Alright, so that's negative b plus or minus the square root of b squared minus 4 times a times c divided by 2 times a, the quadratic formula. This is going to give me negative 246, and then underneath here, the discriminant, when you calculate 246 squared minus 4 times negative 24 times negative 270, that comes up to 34,596, I should say. And then we're dividing that by 2 times negative 24, which is negative 48. And it turns out that that 34,596 actually is a perfect square, and the square root of that number is 186. And then I get two answers, one of them being 60 over 48, and the other one being 432 over 48. And when I reduce those, I get my two critical numbers, 5 over 4 and 9. And these are my two critical numbers. All right.